Welcome students to the online class Standard 8th Subject Science. Lesson number 3, Force and Pressure. So student, let us see the topics which we are going to cover in this slide. The first topic is pressure, second topic is unit of pressure, third topic is pressure on solids, and fourth topic is pressure on liquid. So let us see all this topic in detail in these slides. So let us begin with the first topic. The force exerted perpendicular on a unit area is called as pressure. Okay, presently we are considering, student, only the force acting on an area in a perpendicular direction. So always to keep it in your mind that pressure is nothing but it is the exerted force on a unit area. Okay, and pressure is given as force upon area on which the force is applied. Suppose on a particular area some object is been kept, so the force which is exerted perpendicular on that object on the particular area is known as the pressure applied to that object. Okay, so student, pressure is given as force upon area. The unit of pressure is Pascal and the unit of force is Newton, and the unit of area is meter square. Okay students, so the SI unit of force is in Newton, area is measured in meter square, therefore the SI unit of pressure is Newton meter square. It is also known as Pascal. In atmospheric science, students, the unit of pressure is bar. Okay, so 1 bar is equal to 10 is to 5 bar. Okay, it is denoted by PA, and pressure is always a scalar quantity. Student, moving ahead with the first topic, that is pressure on solid. Student, as we know that air pressure is exerted on all the objects kept in air. Similarly, when a weight is kept on a solid, pressure is also exerted onto it. This pressure depends on the value of the weight and contact area between the two. Okay. To understand more clearly, student, let us perform one activity. Suppose that you must have noticed that a vegetable vendor carrying a basket on her head. So why do she keeps a twisted piece of cloth on her head below the basket? So that the pressure which she is facing on her head should be reduced or should be come on to that piece of cloth, twisted cloth. Okay, that's what they want to say. As you can see in the picture, student, that the table onto which the books is been kept, the block of book is been kept on one after the other. So what does this shows? It shows that the table is been exerting the pressure of all the object onto it. Okay, but if the books has been divided into parts, the pressure will also be distributed as the book will be distributed in that area. Student, is it possible for us to stand at one place for a long time? No. Why? Because the pressure we will be feeling on our legs. Okay, so it is just not possible for us to stand at one place. Okay, similarly, it is just not possible for any solid to bear such a load for a long time. Okay, in order to bear the load of any object on a solid, the object should be distributed. Now student, let us move with the next topic, that is liquid pressure or pressure of liquid. To understand it more clearly, let us perform one activity. As you can see in the above slide, we have taken a plastic bottle. Okay, take a 10 centimeter long piece of glass tube on which a rubber balloon can be fitted. Okay, warm up one end of the glass tube and gently push in the bottle at about 5 centimeter at the bottom. To avoid water leakage, apply molten wax on the side of the glass tube. Now fill the water slowly in the bottle and see how the balloon inflated. What do you observe, student? The pressure of the water acts on the side of the balloon as well. Okay, so as the pressure will be put onto the bottle, it will exert into the onto the balloon. Okay, what happens, the balloon will get pressure onto it. Okay, so student, as you can see in the above slide, we have taken a glass jar, we can say. Okay, it's a glass jar or a plastic jar. So we will take a piece with a thick needle into it, and we will start making holes onto it, as you can see on the slide. Okay, 2-3 holes we are going to make onto it. Now fill the water in the bottle up to full height, as shown in the figure, as shown in the above slide. So student, the holes which we have made, when we are filling the water into the jar or into the bottle, what happens, because of the pressure, the water jet you will be able to see coming out of the bottle. Okay, from the hole, top will fall closest to the bottom. The jet from the lowest hole fall fastest from the bottom. Also, jet coming out from the two holes are same level, falls at the same distance from the bottom. What is understood from this, students? It shows that at any one level the liquid pressure is the same. Also, the pressure increases as the depth of the liquid increases. Okay, so it's all about the pressure on liquid. Okay, so as we have seen that, as we have done 2-3 holes onto the bottle, it faces the pressure onto the bottle. As when we have made the hole, the water comes out and pressure out the water. Thank you.